Welcome to video clip 2.3, in which we will investigate exclusive and parallel gateways. So far we only have seen sequential flow in a process, but of course that's not sufficient to express what we like to express for business processes. And therefore we look at the application scenario, continue the application scenario with the parts that are shown in black here. So the gray, which is grayed out, we already took a look at. So we look now at this new material here shown in black. So this is followed by checking whether the ordered product is available in the inventory. So this is done after entering the details of an order in an IT system. If the product is available, it will be obtained from the warehouse. Otherwise, the materials for the product need to be obtained and the product be manufactured. So we look at the situation when the material is not in the warehouse and we need to do something else. Basics to gateway. So sequence flow can only express the ordering of activities in terms of sequences, which is often not sufficient, as I mentioned. Richer execution conditions can be expressed using gateways. Gateways have the generic shape of a diamond and are supplemented with a symbol that specifies their behavior. And gateways can be used for splitting and joining sequence flow. And in this section we introduce the data-based exclusive gateway. This is also called exclusive gateway or XOR gateway, and also the parallel gateway or the AND gateway. Let's start with the exclusive gateway. The exclusive gateway can be used as a split and join node. And looking at the split, it's called XOR split. XOR stands for exclusive OR split, so the exclusive OR split, meaning from a set of alternatives, exactly one alternative is chosen. So this XOR split has one incoming edge and several outgoing edges, and only exactly one of the outgoing edges is chosen at each signaling of the XOR split. Conditions attached to the outgoing edges are evaluated, and these decisions are used to decide which way is taken, which of the outgoing sequence flow, conditional sequence flows are chosen. Flow is chosen, to say just as one is chosen. On the other side, we have the XOR join, the exclusive OR join, and this construct is used to merge the paths. So in the XOR split, we spread out, so there are different alternatives, and these different alternatives will then be merged again in the XOR join, and this is also called exclusive OR join, again XOR for the exclusive OR. So this construct merges alternative paths, and for each incoming sequence flow that is signaled, an outgoing sequence flow is generated. So let's look at the example we have here in the lower part of the picture. We have here the XOR gateway, that is a split gateway, one incoming edge and several outgoing edges. And you see the conditions of the gateway attached to the outgoing sequence flow. And the conditions say product in stock or product not in stock. So after we check the inventory availability, we can decide whether the product if the product is in stock, we obtain it from the warehouse. If the product is not in stock, we have to first obtain it and then manufacture the product to continue the process. The XOR join then merges these two alternative paths again, so that in any case we package the product afterwards. So each process instance starts here in the beginning, and it might go this way or it might go that way. Yeah? So each process instance either goes the upper way or the lower way. Okay. Now, what is the exact semantics of this? We need to detail this a bit more. So the exclusive gateway semantics. It's the semantics of the XOR split in more detail. And we discuss this in the example you see here on the right-hand side, where we have an abstract example. So at this point, abstract examples are good to explain the the key concepts of the XOR split. We have the activities A, B, C, D, E, and we have one exclusive OR split, goes here, and there are these conditions attached, condition 1, condition 2, condition 3, and then there is one sequence flow with this little black line, and this is called the default flow. Right, the standard says that these conditions are once activity A has been executed, we need to evaluate, we need to decide which way to take actually. And this is done by evaluating the conditions of the outgoing edges of the XOR split, and this is done in specific order. We do not know in which order that will be, so the model does not tell us in which order these conditions will be evaluated. It's not that condition 1, condition 2, condition 3 is evaluated in that order. It can be in any order, almost in any order. So the default flow is always the last which is being evaluated. So that's other than that, we have no information about the ordering in which these conditions are evaluated. The arc of the first condition evaluated to true is then signaled. So using the specific order, the first condition that evaluates to true, that will be chosen and the respective arc will be triggered. All other arcs will be discarded. There can be a default flow which is evaluated last, and its condition is always evaluated to true. And the default is, of course, useful. Otherwise, there's a danger that the process gets stuck here. If all conditions evaluate to false, the process could not continue. In this case, the default flow helps us to deal with this situation and continue the process. Let's look at the example and let the evaluation ordering be condition 1, condition 3, condition 2 default. That's possible since default is the last in this ordering, and we don't know which, in general, we cannot deduce from the model the order in which the conditions will be evaluated. Okay, so let condition 1, which is evaluated first, evaluate to false, so we need to look at the next one. Let condition 3 evaluate to true, very good. So condition 3 is evaluated to true, and then D is executed. And the others are not executed, so B is not executed, C is not executed, E is not executed, D is started. Now we can come back to what we took a look at in the previous video, and that is the state transition diagram of activity instances. And here we see that all activities are in the init state, initially are in the init state. And once D is selected, B, C, and E are no longer required. Therefore, B, C, and E can go to the skipped state. So this is an example where activity instances come from the init state to the skipped state. And of course, D, if selected, goes from the init state to the ready state and is then ready for execution. It's worth mentioning that the XOR semantics, so the semantics that exactly one branch is chosen, is preserved even if the conditions of the edges are overlapping. By overlapping conditions, I mean that in a given situation, several conditions evaluate to true at the same time. So this is not forbidden. This is not forbidden by BPMN. And let's see how BPMN would handle that. Using an example. So we have, again, the three conditions, condition 1, condition 2, condition 3. And the condition 1 might be cost less than 200. Condition 2, cost is less than 1,000. And condition 3, cost is less than 10,000. And the evaluation ordering is the same as before, condition 1, condition 3, condition 2. And assume that the data object cost has the value of 500 for a particular process instance. Okay. So what happens in the case that cost equals 500? So first, condition 1 is evaluated. Cost is 500, and 500 is not smaller than 200, so condition 1 evaluates to false, is not taken. We need to evaluate the next condition. Condition 3 is then evaluated. as the order of evaluation tells us. The cost is less, so 500 is less than 10,000, yes, so condition 3 is evaluated to true, and again D starts. Yeah, so in this case, and all B is not started, C is not started, E is not started. So we have, again, the XOR semantics is correct. Exactly one of the outgoing branches is chosen. But if the evaluation ordering would be a different one, if condition 2 would be evaluated before condition 3, then condition 2 would be selected. So that means from the model you cannot tell, if you have overlapping conditions, which, in certain situations, which of the branches are actually taken. So and of course notice that the ordering of the evaluation is not related to the layout of the activities and of the edges in the model. Yeah? So, and that brings us, we come back to this in the modeling guideline. So first of all, we should always use default flow with an exclusive gateway. And I already mentioned it. If neither condition evaluates to true and there is no default flow, the process cannot continue. Yeah, so in the previous example, if we had a condition, neither condition 1 nor condition 2 nor condition 3 would be evaluated to true, and we would not have the default flow, the process would be stuck there. And this is something we do not want to see, of course. Okay, so therefore we need to have an exclusive default flow with an exclusive gateway. In addition, if you want to be sure which path is taken in a certain situation, you should make sure that the conditions of an exclusive OR gateway are non-overlapping. We discussed that also in the previous slide. So the conditions of an exclusive gateway are non-overlapping. And a nice example of a non-overlapping condition is here in the lower part, where we check the inventory availability and either the product is not in stock or the product is in stock. So if you have Boolean variables, it can be either true or false. If it's true, it goes that way. If it is false, it goes the other way. That's an easy way, and of course a way that we see quite often in process models, and that is always safe because either you go one way or you go the other way. If you have 3 or more outgoing edges, then you need to be a bit more careful there. Let's continue. Let's say expand on the application scenario to introduce additional concepts. So after the product has been manufactured, subsequently the ordered product is packaged and shipped to the customer. At the same time, an invoice is sent to the customer from whom a payment is received later. And once the product has been shipped successfully and the payment has been received, the order can be archived. So here we see that that there is at the same time, an invoice is generated, or invoice is sent to the customer. Here we have the possibility, or it's not specified exactly in which order, but it can be at the same time. So it can be concurrently to the other activity. And to express concurrency or independence of execution strands, we use the end split or the parallel split. In the end split, all outgoing sequence flow arcs are signaled. So it's not just one selected, but all are selected and all are signaled. And this allows modeling independent concurrent execution paths. So the example we have here, that is a representation of what we've seen in the text of the process description. So after the product has been manufactured, we do 2 things concurrently. We can package the product, ship or issue the shipment, and concurrently to that send the invoice and receive payment. And only after that happens, after both had happened, we can archive the order. So it is called parallel split, but we need to be a bit careful about the term parallel in the sense that it is not required that the 2 branches are executed at the same time, so really completely in parallel. This means the end split just tells that these executions are independent from each other and can progress as they like. Right? So they can be overlapping. They can be overlaps in time. So packaged product can be done at the same time as the sending of the invoice. But it can also be before that and can be after that. However, we need to make sure that the shipment is issued only after the product is packaged, and the payment, of course, can only be received after the invoice has been sent. So these constraints are, we need to make sure that these constraints are fulfilled. But other than that, the lower part of this end split and the upper part and the lower part can be executed independently from each other. All right, let's look at the end join, which is also called a synchronizing join. Why it is called a synchronizing join? Well, because these the parallel branches can be synchronized again. So the end join would only trigger its outgoing edge if all of the incoming sequence flows have been signaled. So in this case, if package product has been executed, issue shipment has been executed, send invoice and receive payment has been executed, and this edge is triggered, and only in this case the end join fires, the end join synchronizes these two branches and then signals its outgoing edge so that we can then execute archive order. So the end join synchronizes all incoming sequence flow arcs, and only if all incoming sequence flow arcs have been signaled, the outgoing arc is signaled. That concludes video clip 2.3, in which we discussed exclusive and parallel gateways. We took a look at exclusive gateways and parallel gateways, looked at the syntax and semantics of these. In particular, the XOR split has quite an interesting execution semantics that not everybody is aware of. So I think that was quite, I think it's quite useful to know also these parts of the semantics of the XOR split. And we finally discussed the modeling guidelines.